Everybody, this is Tony DeLigio with Plastics Technology Magazine, and I'm joined today by Tim Stewart with Beacon Engineering Solutions, and we're here to talk about Beacon's submission for the inaugural Hot Shots Parts competition. Got a very interesting part here. It's the center kind of structure and skeleton for a line of ID card printers based on a polycarbonate with some carbon fiber and Teflon. So I guess, we'll just kind of dive right in. It certainly just at first glance looks incredibly complicated. I mean, the tool must be really involved. But yeah, Tim, if you want to talk a little bit about the part that you guys submitted and what kind of made it challenging and how you guys overcame those challenges.
Yeah, there's a lot going on. Thanks, Tony. Appreciate it. This part, we did the version 1 back in about 2009, and the customer was new to us at that time. So there was a lot of risk involved on both sides. But, that's really where innovation comes from, is getting outside your comfort zone, pushing the boundaries. And the real victory here was the strength of collaboration between Beacon and our customer to push those design boundaries and come up with a product solution that really has set them apart in the marketplace.
Okay, excellent. And you mentioned in the submission that the amount that you guys had to use kind of a mold flow and warp analysis to kind of inform where you were putting the gates. If you want to talk a little bit about that process, and if you can get into it, maybe the number of gates and how you decided where to locate them, and what were the challenges there?
Sure. Yeah, so this part is a consolidation of 3 separate parts and versions prior to our involvement. And the issues the customer ran into were that you had 3 separate molded parts that then they mechanically assembled together. And if you think of an ID printer, or any printer for that matter, tolerances are hugely important. In order to achieve the resolution you're trying to have in the finished printed product. And so they had numerous quality issues, with parts not lining up properly in their assembly process. And so, the idea was, can we mold these 3 individual parts as one part? And that was the real victory, that not only did you go from 3 molds to 1, so significant CapEx savings, you also eliminated roughly 66% of the molding hours, because you're molding 1 part versus 3 separate parts. You also eliminated the assembly operation and then the associated misalignment issues that came along with it. And so it really was a huge victory. But to get there, as you touch on, we did a lot of mold flow and warp analysis, fill analysis, because not only was fill important, but warp was a significant issue, again, for achieving the tolerances. And so, several iterations between, we built all of our tooling in China, or at least 95+% of it. We've been over there for about 25+ years. So we've got good partners that we've worked with, and a lot of iterations. And so it was a real collaboration from the customer to Beacon and to our tooling partners to achieve the desired result.
Okay, definitely. And obviously you guys had put on there that RTP was the material supplier, and it's kind of an interesting mix of materials, performing some pretty interesting functions. So I don't know if you want to touch on how you came to the material you used and what you were asking that material to do in this particular application.
Yeah, we think very highly of RTP. They've been a long time and trusted and valued partner for Beacon. And they were also, I neglected to mention, part of that collaboration process. And so it is a polycarbonate base material with 10% carbon and 15% Teflon. The carbon is for grounding. There are some electronics, and you can't have electrostatic buildup. And the Teflon is to address any squeaking issues between, if you think of a printer, there are a lot of mating moving parts. And so that's what the Teflon is for. All right, so this image right here is an image of the finished product. And over on the left, we've got the part on its own. And so this part right here, if you can envision, fits inside, and again, it's the framework that all these internal components mount to, as well as the external enclosures.
In terms of determining, as much as if you can get into the details, like where the gates would be or how many gates did you end up using, and then if you want to share any details on the tool in terms of the independent
Sure.
actions. I mean, it looks like there's a lot going on there, but
The big challenge with this part from a tooling and molding standpoint was, as I mentioned, the tight tolerances. And so if you see all these bosses on the side, and they're on both sides of the part, as you can kind of see them sticking out all over the place. So not only do they have tight tolerances, but they also have zero draft on them. And the unique solution that we came up to address that, because not only did you have potential part sticking issues, but we also had potential venting issues. And so on the slides for the sides of the part, we embedded some hydraulic plates, and those plates hold the part on the core and the cavity while the slides retract. And so that eliminated the sticking issue, or at least counteracted it. And then those plates also, because they're inserted, eliminated the venting issue. And so that's really was kind of in addition to combining three parts into one, the sequence of how the mold opens and how it's designed is really a win and something quite unique.
well, Tim, thanks again for spending some time with me today to talk about your guys' submission to the inaugural Hot Shots parts competition that we're going to have at Molden 2021. We look forward to seeing the part there in person and encourage everyone who's there to come and check out all the parts and vote for the best one. So thanks again.